equation, vocabulary, and expression, vocabulary. So we're going to start with page 1, and this is our first quarter table of contents, and you should already have that there. So for our first one, we've got equations and expressions. Vocabulary. And that's going to be on page 6. Actually, for you guys, it's going to be on page 6. For me, it's on page 7. So I've got something else on page 6. Okay, so we're going to turn to page 7. I'm going to zoom out so you can see what I'm doing here. I'm going to take this page, and just so I can get it in half, I'm going to fold that page inside half, and then I'm going to open it back up. Okay, so that gives me a nice straight line there. I've got wide ruled paper, so I'm going to count down 4 lines, trace that blue line, then I'm going to count down 6, trace that blue line, 7, then our vocabulary words that we're going to put in here are associated with equations and expressions. So the first one, and we're going to put these words in the middle, is a numerical expression. Then we have algebraic expression. Next, we have variable, and we have constant, we have term, and like terms, and we'll have the substitution property, coefficient. Okay, so I want you to pause the video here and fill in your own definitions underneath.
I am so sorry that you've been interrupted multiple times today. I have just...
So fill in your own definitions under the word, and then we'll put some examples on top of the word. So stop the video here and fill in your own definitions. So a definition of a numerical expression could be an expression with numbers and operations only. An example of that could be 4 plus 2. That is a numerical expression. An algebraic expression is an expression with numbers operations and variables. Okay, so we could have 4 plus a, or we could have 3x squared plus 2. Those are both algebraic expressions. You could even have B plus C. Could be all variables. That would also be an algebraic expression. XYZ could be an expression, and these would be all multiplied. Multiply x times y times z. So a variable is usually a letter. Sometimes it could be a symbol that represents an unknown number. So we're looking at A, B, C, dot, 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 X, Y, Z. A constant is just a plain old number. It does not vary, so it does not have a variable with it. It's just a plain number. So you may have heard the phrase, it is what it is. It's constant. It's not going to change. 4 is 4. Even some rational numbers. 7.4 is 7.4. Negative 3 is negative 3. Cannot change those. They are constant. A term is the stuff in an expression, whether it's a numerical expression or an algebraic expression. It's just the stuff in an expression and also an equation that are separated by an addition or subtraction. For instance, 5a to the 4th minus 4x to the 2nd plus 2x plus 5. This is a term. This is a term. So 5a to the 4th is a term. 4x to the 2nd is a term. 2x is a term. And 5 is a constant. So those are terms. So like terms are going to be terms. Talking about these kinds of terms. Terms with the exact same variable and exponent. It's got to have the exact same variable and exponent. So I'm going to give you a couple of examples here. If I had 4a to the 2nd plus 5b plus 2a minus 7a to the 2nd plus 3b minus 5. Made a very long expression there. So I'm going to identify terms that have the exact same variable and exponent. So that would be 4a to the 2nd. And I see 7a to the 2nd here. Not 2a because it does not have to the 2nd power on that a. So I'm going to highlight this in the same color, and I'm going to take the subtraction sign in front of it, so what goes in front of it stays with that term. So that will combine to make -3a to the 2nd. If you're not comfortable with integers yet, don't worry about that part. So then next, I'm going to find like terms with 5b. So plus 5b, 2a, no. Plus 3b, yes. So the plus and the 3 and the b. Those are like terms with plus 5b. So positive 5b and a positive 3b together make a positive 8b. So it goes like that. Then I've got right here plus 2a. I have nothing that will combine with plus 2a, so I just write it on down here. And then I've got minus 5, and I have nothing that goes with minus 5, so I just write it down there again. That's combining like terms. Please do not panic about that yet. We will have more on that later. Just wanted you to know what like terms are. Let's go on down to the substitution property. This is going to come into play when we're talking about equations. So if we say if, and it could also be used in equations or expressions. If A is equal to, let's make up a number, 6, then 6 can sub in for A, or A can sub in for 6. Okay, if they're equal to each other. So let's think about playing a basketball game. If you're on the basketball team, and let's say A is the starter. Okay, so in the basketball game, we have A plus 2, A and 2. And let's say A gets injured. We need the person that plays the same position as A to go in for the person coming out of the game. So we're going to substitute in with parentheses 6, because they're equal to each other, they play the same position. 6 plus 2, so we can evaluate that expression to be worth 8. When we're dealing with equations, we will use this property when we're checking our solutions. Checking solutions to equations. All right, and the last one is a coefficient. That is the number that multiplies a variable. Typically, it is found in front of that variable. And when I say in front, I mean to the left. Okay, so if we're talking about 3D plus 2, this is the coefficient. I can't see anymore. Is the coefficient because it is telling this D, whatever you have, 3 times that. And it's directly in front of that variable. It is root word being coefficient. It occurs in with the variable. So that's all we have